The plan for this lesson is to study the properties of the normal distribution. We will start by discussing random variables, probability distributions, then discuss the properties of the normal distribution. To understand and appreciate the normal distribution, we need to discuss what is a random variable and what is a probability distribution. A random variable, represented by X script, maps potential outcomes in the sample space of a random experiment, which is presented by the big omega, to real numbers. This is very helpful in analyzing and quantifying randomness in experiments. Here is an example. Suppose that we have an experiment that says flip 2 coins and observe the number of heads. The sample space is 2 heads, head and a tail, or tail and a head, and 2 tails. Now applying the random variable on each outcome, we get 2 for 2 heads, 1 for head and a tail or tail and a head, and 0 for 2 tails. This is one way to look at the experiment, but remember, the goal is to quantify randomness in the experiment, which means we want to be able to express possible values of the random variable and the probabilities of observing these values. So what we want to do here is to compute those probabilities. The probability of getting 0, the probability of getting 1, and the probability of getting 2. A probability distribution describes the probabilities of likelihoods of different possible outcomes of a random variable. As we just saw in the previous example, our random variable had 3 outcomes, and we want to compute their associated probabilities. And there are 2 cases for probability distributions. The discrete case, there is a probability that we can compute for each value, and the continuous case, the probability needs to be computed over intervals. Some notations we use with probability distributions: X has the distribution F, and X has a normal distribution with parameters mu and sigma square. Now we get to the normal distribution. F of X is a probability density function that describes the normal distribution in terms of mu and sigma. And one notable thing about normal distribution, it's a fast decaying function. So as soon as we leave the mean by 1 standard deviation, we start to observe this decaying behavior. And there is this rule which is called the 68, 95, 99.7 rule, which states that 68.27 of the observations live within 1 standard deviation, 95.45 lives within 2 standard deviations, and 99.73 lies within 3 standard deviations. This is what we want to cover about normal distribution at this point. In summary, we covered random variables, probability distribution, and properties of the normal distribution.